Kotlin 2.4 introduces collection literals. You can finally get rid of those calls to list of and set of and just use brackets. Now, you might have seen this syntax in annotations previously, but now collection literals are available in the rest of your code. And when we put them together with the new name-based destructuring feature, it makes for a pretty neat effect that I'm going to show you in just a minute. Now, if you're ready to unlock this feature, it takes just a few seconds to turn on the flag. You just add this compiler argument here in your Gradle build file and synchronize the Gradle project. Now, even though this feature is already available in Kotlin 2.4, the Kotlin plugin for the current version of IDEA doesn't recognize it yet. So if you're using IDEA 2026.1, you'll get the red squiggly lines like you see here in the IDE. Now, Gradle's going to run the code just fine. This is only a problem in the IDE. So if those squiggly lines bother you, you can just download the early access preview of IDEA 2026.2, or you can just hold out for its full release. All right, once you've got the compiler flag set up, you are ready to start. Now, when we write out a collection literally, like I'm doing here, what type does that resulting collection have? Well, it actually depends on the context. In this code, I haven't specified what type this books variable should have, and when that's the case, it defaults to a regular list of strings. But by explicitly specifying the type of the books variable, we can change the type of the collection that's created. So if we need it to be mutable, for example, we can simply specify it with a mutable type like this. Collection literals work with sets as well, so we can just as easily change this to a mutable set. Now, of course, to keep things simple, I've just been assigning our collection literal to a variable, but we can also call functions with a collection literal. So for example, in this code, we're creating a regular list because that's what the printBooks function accepts down here. Alternatively, we could replace this with a call to add to books like this. And when that's the case, it's going to create it as a mutable list because that's what the parameter type is right here. Now, we can't use this new syntax with just any collection type. So for example, if we were to change this to a linked list like this, even after we give it the import, we'll still get a compiler error here. And that's because when the type doesn't support collection literals, it's going to fall back to just creating a regular list object. And we can't assign a regular list of strings to a variable that's declared as a linked list of strings, which is a more specific type. And that's why we're getting the error here. However, we can, of course, assign it to a collection of strings because a list is a subtype of collection. So the collection type has to actually support collection literals in order to be used with them. Well, what do we have to do to make a collection type work with collection literals? The secret is to add an operator function, and you can even add it to your very own classes. For example, here I've introduced a new iterable named bookshelf, which just holds the books in an array. If we try to assign the collection literal to a bookshelf object, we're going to get a compiler error right there. So let's add the operator function that I had mentioned. And this one has to go on a companion object, so we're going to start by adding that. And then we introduce the operator function here named of, and we pass in a vararg and instantiate the class. And with this change, we no longer get the compiler error that we had gotten up here. Now, like I said, this operator function goes on the companion object, and there are a lot of restrictions that are imposed on this operator function. And I'm not going to go over all of them here, but I'll include a link to the keep document in the description of this video so that you can read all about those restrictions. But one of the more notable ones is that this operator function cannot be declared as an extension function. So if there's a third-party collection library that you want to use with collection literals, just keep in mind that you won't be able to simply add an extension function to make that happen. So collection literals are a nice addition to the language, but when we use them in conjunction with the new name-based destructuring feature, something pretty cool happens. So here you can see I'm using a collection literal on the right, and I'm doing destructuring on the left. And the effect is that we make multiple assignments on a single line in a single assignment statement. Now, this isn't an entirely new capability. We've always been able to just load up a list and immediately destructure it like this. But the code at the top is a more concise way to assign multiple variables in one shot. It gives us a syntax that's actually pretty similar to parallel assignment in many other programming languages out there, like Ruby, Python, and Go. Now, in our case, it's still done by destructuring or unpacking the collection on the right-hand side. But hey, maybe someday Kotlin could include an optimization to avoid creating a collection in a case like this. Who knows? Well, I'd love to hear what you think about this new collection literals feature, so talk to me in the comments. I've also got a link to the Keep in the description of this video, so if you want to read more about it, that's a great place to get all the details. More videos and live streams are on the way very soon. Thank you so much for watching. Remember to like this video, subscribe to the channel, and turn off the light when you leave the room.